Hey, my name is Tomer Peleg, and I'm here today to talk about balance. But what is balance in the world of infrastructure, and how can we get it? Well, we all know that we rely on our infrastructure. Managed or not, it's the same. But while we tend to focus on factors like functionality, availability, and if we're advanced enough, even cost, that doesn't give us any control. Not to us, and not to our users. So let's break it down. As an owner and maintainer of an infrastructure, I need control. That's a fact. I need to know what is going on in the system, how to react to a crisis, and of course, how to communicate with my users. Which, by the way, always seem to want more. More features, more support, but most importantly, more independence. So today I will talk about design, architecture, and the coupling between dev and infra teams in a cluster-based tech. And at the end, I hope you'll see things a bit differently on how to build a proper infrastructure self-hosted. I'm glad to be here, part of PlatformCon 2022, and of course, I will be available for any questions in the Platform Design Slack channel. So let's begin. That's me, Tomer Peleg, a data engineer at Riskified for the past 4 years, a father of 2, a member of a data committee, and responsible for the entire streaming platform of Riskified, including performance, scale, availability, and of course, infrastructure. So Riskified was growing really fast. Our tech, scale, structure, and even the way we think was changing. In our case, the way we manage our resources had to change. But before we understand the what, let's first understand the why. So our starting point was that all of our environments like production, staging, sandbox, and etc. were managing the same AWS account. Resources were provisioned with tools like CloudFormation, some management tools, and even manually. Obviously, it's not maintainable and doesn't have any state. So we started an initiative of splitting them into a set of dedicated accounts. This required us to come up with a solution on how to duplicate the same set of resources across accounts. And what we came up with was, of course, Terraform. So let's see how we can design this solution. We created a dedicated repository in GitHub that will store all TF modules. Each module acts as a vanilla and provides the ability to create a specific resource with an environment-based configuration. Now, of course, Terraform Registry already have some of these modules, but here at Riskified, we prefer to wrap external resources to gain control. We can wrap it with Riskified standards like cost tags for cost distribution, dependencies, and even security. This in order to deliver an easy-to-use and maintain resource. You can see here resources like IAM roles, or the scaling groups, and even cluster-based techs like Kafka, Elasticsearch, and Aerospike. Okay, so we basically built our own registry. Nice, but let's see where do we actually use it. So in the same repository, we created an abstract distribution in different layers. It can be the environment where resources is deployed, region, owning team, and even technology. Each one of its own isolated state and CI/CD. Of course, you can choose whatever fits your needs. And the framework we use in order to create and manage these resources is GitHub Actions as a deployment pipeline. This provides full visibility in terms of what is actually going to change after we apply the execution plan. And also, in our case, the ability to create a new up and running cluster in a matter of minutes. So let's go ahead and build our own cluster-based platform. Here you can see some data cluster, can be Kafka, Elasticsearch, or some other tech that is being created in our cloud provider. As a common use case, let's say we have a master and a follower clusters. Of course, it can also be in a different structure like broker and zookeeper clusters in Kafka. Now, let's say we want to create the same cluster in multiple accounts. In our case, we simply need to provide a different set of configuration in each environment. This can be the region in which we want to deploy, VPC, a list of subnets, hosted zone, and more. In the cluster level, we also want to create components like a service discovery, like AWS CloudMap for dynamic DNS records, IAM role for permissions, and the applied security groups. Now, if you think about it, the nodes of each cluster are not so different from one another. From Terraform perspective, they need the same resources, right? The difference is that each one will be created with a different set of properties. For example, cluster size. We won't necessarily need the same size for both clusters. Or instance type. And of course, volume size to store the data according to the cluster scale. A good example, as mentioned before, is the Kafka brokers and Z nodes, which have an entirely different purpose and require different quotas, but still part of the same data cluster. Also, if you're using some base images to set up your instances, the nodes models is also a good place to configure metadata that will be used dynamically at runtime. For example, we can use a framework like Ansible to run a playbook that will dynamically install and configure the application according to configured tags in the instance level. Okay, so we executed the Terraform plan and the cluster is being created. Now, let's go ahead and deep dive into its architecture and understand how we can design a cluster-based tech that supports a rolling deployment with zero downtime and no data loss. Because let's face it, without it, the alternative is to migrate all of our users to a new cluster each time we have a breaking change. And I will tell you the truth, we did this procedure twice, and honestly, it wasn't fun. Now, if you remember, Terraform created all of our resources, including the actual nodes. For example, AWS EC2 instances. Meaning that if we apply a breaking change, like changing the instance type or AMI ID, Terraform will make the transition for all the cluster simultaneously. This will cause downtime and of course, data loss, especially in a cluster-based tech. So let's check our design and see how we created the ability to separate Terraform from the actual deployment. Now, I know this diagram has a lot to take, but let's focus for a moment on one instance. Other than the fact that each instance is deployed in a different AZ, you can see it's wrapped in an auto-scaling group with max capacity of 1. And the reason we use it is in order to apply changes not directly to the instance, but to the ASG configuration. This configuration will only be applied once we scale the ASG and replace the instance. Sounds great, since now we can roll the entire cluster one by one and apply our changes. Also, in order to gain even more control, we added some additional components which gave us flexibility and observability, like S3 and Secret Manager to load certificates and users and secrets at runtime. Prometheus to collect metrics in both host and JVM level, and CloudMap as a service discovery that lets us create dynamic DNS records according to a custom health check. So let's sum up what we've seen so far. We had a GitHub repository with our cluster configuration, the Terraform model of our cluster, the ability to create it in a matter of minutes, and to apply changes with no impact on our clients. Let's continue and check the actual pipeline where we execute the Terraform and the deployment for each one of our clusters. So we have our cluster up and running and we want to apply some breaking change. Let's see if we can design our system to support it. As I mentioned before, we manage a dedicated AWS account for each one of our environments. Each account is isolated and doesn't have any communication or permissions with the other accounts. So we created a high-level account called management with limited access and permissions and the ability to access each account. This is where we hold our GitHub runner, which actually runs the Terraform execution plan. And now, thanks to the support of our ASG instance management, we're able to separate Terraform changes from the actual deployment. So we can add another step, which will execute the rolling deployment for the entire cluster node by node. And for this step, we'll also use GitHub environments, which will hold the deployment until approval is granted. Okay, so until now, we talked on how things look only from the infra perspective. Let's change our view and understand how we can let some of our control go in favor of user independence. The communication between the development and infra teams is not something new to us. Create, change, delete are usually the operations we're required to deliver as an infra team, and this on a daily basis. And as we grow in numbers, the line gets longer and longer. And we don't have a capacity to handle the load. We try to handle this queue with various solutions, like a dedicated slot in time to sit with developers on demand, a meeting where developers could come and present their requirements, and of course, the famous data on chief who handles simple but repeating requests. We need to find a way to reduce this queue and enable the user, and us, of course, to work. So as you assume, it's a really long line. Let's see some solutions. Here, for example, we took a simple resource in the role of Kafka and delivered the user the ability to be the owner of his own resources. In this case, the user can manage his own Kafka topics, including retention, partitions, and even security with no dependencies. Similar models can be provided in other texts in order to deliver independence and reduce the coupling between teams. And the location of these resources is in the user's owning service. This in order to build our resource map and dependencies, and of course, assign data like cost-X for cost distribution. Now, the user can actually work without having to wait for assistance. Another aspect we can deliver is observability. We should always remember that the development teams might not know where and what to look for when using our infrastructure. And they will usually prefer to focus on functionality rather than on things like monitoring and alerts. We decided to make it accessible by collecting the required metrics from both the infrastructure and delivery clients out of the box. And we built it in different layers in order to be able to gather intelligence according to the scope we are focusing on. We have visualized dynamic dashboards that we and our users can use, like overall cluster level view, application level, and even client level, even though each client we deliver exposes different metrics. For example, Kafka Streams, Spark, and other clients in the role of Kafka. Also, based on these metrics, we're able to configure alerts and route them to their owning team. Now, in addition to the ability to manage their own resources, we also want the user to be able to execute operations without any dependencies. So we also deliver some self-service tools. Each supports different texts and allows the user to trigger jobs and interact with his data. As you noticed, we love Kafka, so I'll continue on the same path and describe some of the tools we provide. So as you can see, we allow the user to produce messages to Kafka without even having to set up a service, of course, with schema registry, route data between Kafka topics with cross-cluster support, configure on-demand Kafka connects for ETLs, and even create streams from Kafka as a source to data lake for offline research. So we trust our users and provide them with more power, but we can't lose our guard, and we need to bring some control back, and we do it by using OPA. This is basically a rule set which is being applied on the user's execution plan and secures its operations with some boundaries on what it can and can't do in terms of resource management. We can apply validations on value changes, thresholds, and more that will ensure our defined limitations. And this, without having to actually review it ourselves. This brings us back in control and completes this circle of trust between us and our users. Finally, if I would have to sum up all we talked about today, I would simply advise you to trust your team, understand their business and requirements, be an enabler rather than a blocker, and let some go in order to be able to work and still be in control. Thank you.